Howdy folks. For today's random teardown, I thought I'd do something a little interesting, given the last video was, in my opinion, pretty generic. This is a sound level meter. This one's made by a company called Scosche. This is the SPL 1000, which, if I had to guess, that would stand for Sound Pressure Level Model 1000. So this basically, it's got a microphone in the end, and it will tell you how many decibels the current sound level is. So obviously as I talk, the number goes up, and yeah, so it says DBC here because they correct it for human hearing. It's got a little button on the side. You can press it for min-max, and it'll give you the maximum it's detected and the minimum it's detected, which then updates, and then you can just cycle through them, or you can hold it and go back to live mode. And it's got a little hole here, and there's a little photoresistor, and it basically dynamically turns on a backlight depending on how bright the ambient light is, which is kind of an interesting way of doing it. I can't say I've actually seen a backlight that uses a photoresistor like this before, so I thought that was kind of nice. And it's powered by a single 9-volt battery, and they give you a little little table on the bottom here. 30 dBs is library, 60 is normal speech. It goes all the way up to 140 being jet engine. It's a logarithmic scale, so anyway, I'm not sure how useful that is. Hopefully you know what these mean. I bought this because I wanted to just sort of ensure that I was being safe with some of the things I was listening to, and as it turns out, yes, I am not crazy, and I'm not damaging my hearing with the levels that I'm using. So this, I believe, looks to me like the battery the thing came with, because I've never bought one of these. It says no mercury on it. This could be a zinc battery though, but it hasn't leaked, and I've had this thing for quite a few years, so if it hasn't failed yet, yeah, see, 2012-06, so that sounds about right for when I got this. It mostly sits in a drawer. I kind of needed it for a couple measurements and then didn't use it again, but I'm not sure if that's because it's not really useful or just because I totally forgot that I had it. Probably the latter. So anyway, let's take this apart. Looks like it's got 3 screws on the back here. Yeah, I recommend not listening to things terribly loudly. If you can hear it, for headphones primarily, if you can hear it when the headphones are on, like if other people can hear it, it's probably too loud. So this looks like it's just gonna come apart. Okay, so can I pass this through? Looks like there's a little slot here so I can get the back cover completely off. That would be really awesome. Yes, it looks like that's going to happen. Excellent. So the back comes off. Nothing interesting in there, no markings. And we've got the front. And so the microphone is down there. And it's got some, looks like white silicon goop they've used to adhere that microphone in there. It looks just like a standard Electret microphone capsule to me, so it doesn't look like there's anything special. They do have foam on this side to prevent nasty stuff from getting in there, so that's at least nice. We've got a little rubber insert here over the button, the little clicky button, which has got a nice clicky action. That's very satisfying. And the wires go through a hole in the board. They're obviously soldered on the other side, and I think they're using that bend in the board as a bit of strain relief, which is interesting. And there's a lot of analog circuitry on here. Unfortunately, we have a cob, a chip on board with the epoxy blob on it. So that's unfortunate. So that would probably, in my best guess, be the main processor here with all the software on it. It's interesting to note that there's all these pads around the edge, so I'm not sure if those were used in development for testing purposes. Basically, they'd put a chip in and then they'd basically have a jig that, you know, connects to those pins, and then they could see what the microcontroller was doing, or if there's actually another package, like before they use the chip on board, there's actually, this microcontroller comes in a bigger package. They could actually surface mount solder on here, and they've just gone to the chip on board for production because it's cheaper. I'm not entirely sure. We have a hell of a lot of screws holding this board in, and even more trimmer pots. We've got 1, 2, 3, 4, 5, 6, 7. Yeah, 7 trimmer pots. So this thing is obviously tweaked by someone with a gray beard to make sure that it's accurate. And I do not want to touch those. So this actually comes off. This is it's actually a nice material. I kind of like the construction of this. It feels very high quality. From what I remember, this was actually relatively expensive. I bought this at a store. I didn't buy this online, so I probably wasn't the smartest idea. But anyway. So let me see if I can get this board out, and then we'll decode all the chips. Gonna make sure that I do the screws and none of the pots, or this thing will probably destroy the pots if I try to spin them that fast. Okay, so let's see, does this just lift out? I think it will. Excellent. So the front is just a piece of clear plastic, which actually is quite nicely inset in there. It's a little bit bigger than the window itself, and it's got little posts and holes to align it. So that's nice. And the front of the board, or the back of the board, I guess, we've got a little rubber dome button with the contact there, and we've got the display. Okay, so we've got a special piece of plastic here, which is how they get the two-tone plastic. So this is actually behind the window, which is interesting. We've got the LCD here. Now this right here must be the LED for the backlight. So it's just a single LED that's firing into the display, and there's obviously a diffuser behind that, which sort of spreads it out quite evenly. A little bit more on the sides, actually, if I remember correctly. And there's our good old photoresistor there. And that's actually, it looks like it's inside of a metallized module. Yeah, and there's a zebra strip along the top here. So I'm going to try and not remove that. There's nothing underneath it, so I'm just going to try not to disturb that, because zebra strips, they suck to get back on. So it's basically all the components are on this side, and there are quite a few more than I would have expected, but again, I guess it is analog, so what do you expect? We've got some MELF diodes. Gotta love those. Most end up lying on the floor. Yes, that's what MELF stands for, if you talk to any real engineer. This one didn't seem to like the reflow process. It's a little bit, how you doing there? It's almost didn't make it on the pad, but it's good enough. So we've got an interesting electrolytic which is mounted on top of this IC here. It's 105 degrees C rated. How big is that? 22 microfarads at 25 volts. It's a Chang capacitor. I'm not going to try and decode the circuit here, but but I'm sure from the part numbers of these ICs you can work out the signal path. So here, where's my magnifying glass? So here we've got the microphone input here. We've got some caps, and resistors and stuff. We have our first part here, which is a Texas Instruments TL062C, which is probably an op amp of some kind to amplify the signal. And I'm assuming the signal passes around this side here into this part here, which is another TL062C, so that would be probably another op amp, possibly getting more gain, or they're doing some sort of filtering on the signal. I'm not entirely sure. I am not an analog engineer at all, so analog voodoo, not a clue what's going on. Give me my ones and zeros any day. This part here is another TI part, 27M2C 03M. Not sure what that could be. We have the largest part here, which is a 16-pin device. This is an ST HCF4053. And we've got 3 devices here, which are all, actually no, these 2 devices here, the ones on the top and the left, are the same TL062C what I'm going to call op amps. But the part in the bottom is a TI OP07C, so that's probably an op amp as well, but a different kind, so possibly a better op amp, precision op amp they needed for that. Another TL062C, so another, probably an op amp. And this part that was underneath the cap is another TL062C. And this part here, which is a 14-pin package, is an NXP HEF4013BT. So would that be 4000 series logic? And that's it for the ICs, and then we've got our blob here. How many pins is that on a side? 2, 4, 6, 8, 10, 12. Okay, so that would be a 48-pin package if it populated all the pins. So that's a pretty substantial chip. Now, the reason for that's probably because they're using that obviously to drive the LCD directly. So obviously it would need all the pins for all the LCD segments, and it would have a built-in LCD driver, etc., etc. But it's quite nice. I don't see, I mean, it's relatively well done. There's a few components that are kind of crooked. I do like the way that they soldered the battery on the other side, because that provides a little bit of strain relief on this, so that you don't rip those joints out, which is kind of nice because, you know, with a 9-volt battery you've got the loose wires that, you know, the user has to actually plug batteries into this. Although, given by the fact that it's still got the original battery, this thing doesn't really use a terrible amount of power. I'd assume probably the backlight probably draws more power than anything else in this. I don't see a crystal anywhere, so it must be using something like an RC oscillator or something internal to the chip for a clock source. Interesting. Well, hopefully that was interesting. Thanks for watching.